Okay, this video continues our discussion on ellipses, and we're going to talk specifically about a concept called eccentricity. So, the eccentricity of an ellipse will tell you how circular or how stretched out that ellipse is. So what we're going to have to figure out is the value of c, which we get c from our focus formula, right? So the focus, we do c squared equals a squared minus b squared, which means we take the square root of that c would be the square root of a squared minus b squared. And so we think about that in terms of what our focus is, what our foci are. And then A, remember, those are the coordinates of the vertices, so how stretched out it is on the major axis. Okay. Every single ellipse will have an eccentricity value somewhere between 0 and 1. And then here's a note to think about. As E gets closer to 1, the ellipse will become more elongated. And if E is close to 0, the ellipse is more circular. So I'm going to jump into an example. If I know something about the eccentricity, can I figure out the equation? And then can I sketch the graph? Okay, so what I know right now is that the foci are at plus and minus 8, comma 0. Okay, so the foci satisfy that equation, c squared equals a squared minus b squared. And then recall that a squared and b squared are the numbers underneath x squared and y squared in our equation. So, what else do I know? I know the eccentricity is 4 over 5. Now, that's supposed to be c over a, right? So, the eccentricity is c over a, 4 over 5. But the coordinates of the foci are 0, comma, plus or minus c, right? So how can c be 8 and also 4? Well, trust what you see for the foci. The eccentricity value could be reduced, and that's what's going on here. So instead of thinking of this as 4 over 5, I'm going to think of this. I know that c is actually 8 because of my coordinates of my foci here. So I actually know that it's 8 over 10 instead of 4 over 5. Okay, it's the same fraction, it's just been reduced. Alright, so if our eccentricity is 4 over 5, I know the c value is actually 8. I'm going to think of it as 8 over 10. That means that I have c squared. That means I have 8 squared equals 10 squared minus b squared. So if I solve this, that's going to give me 64 equals 100 minus b squared. So that would tell me that b squared would be 36. Now, when I go to write my equation, I know I have x squared over plus y squared over equals 1. The question here is, you just got to be careful. The foci, those are y coordinates, which means that our foci are on the vertical axis, which means it's stretched more vertically, which means that a squared is the number underneath y, not the number underneath x. So a squared is, if a is 10, a squared is 100. That goes underneath y. And then the b squared value goes underneath x. This would be 36. And so that is our equation there. If I wanted to graph that, it's stretched 6 along the x. It's stretched 10 along the y. And we could get that ellipse from those points. Looks something like that. Now, you might think, well, I'm going to go ahead and plot the foci as well. So the foci are at plus or minus 8, comma 0. So you might think, well, this is pretty stretched out, right? It's a fairly stretched out ellipse. It's not quite circular, right? It's far from circular. And so think about your eccentricity value. It's 4 over 5, which is a lot closer to 1 than it is to 0, right? So we said if the eccentricity is closer to 1, the ellipse is more elongated, and if it's close to 0, it becomes more circular. So this is a case where it's pretty elongated. I'm going to come back to here to Desmos and think about these values. So here I have that a is 3 And my C value is given from that equation, a squared minus b squared. Right now it's 2.23. So this would tell me the eccentricity value, which in this case would be about 0.7. And my ellipse is kind of elongated. This is not the equation that we just looked at. Okay. What I want to show you is if I bring A closer to C, okay, so if I bring A back down, now C is changing as well, but look what happens when A and B are the same number. If I just make A 2, look at eccentricity, it's 0. Now, this isn't an ellipse, this is a circle because A and B are the same numbers. And so for an ellipse, the eccentricity can't be 0, but it's going to get really close to 0, right? If we make that A value really close to B, it's going to get really close to 0. Look at our eccentricity value. As I make A get further away from B, then C is changing, and look at the value. Our ellipse is very stretched out. Look at the value of our eccentricity, C over A. It's getting really close to 1. Now, it will never reach 1, but it's getting closer and closer and closer to 1. That number is jumping up really high. It's almost 1, okay, because this is so stretched out. But that value of C, that value of E, the eccentricity value, will tell you a lot about the shape of the ellipse in terms of is it circular or is it elongated.